Hi everyone, this is the second integration by substitution video in which we'll be looking at a work example to apply what we've learned theoretically onto an exam style question. So this is the example exam question that we're going to be looking at today. Using the substitution method, find the integral of cos 3x all over e to the power sine 3x dx. So our first step is determining what we are going to choose as our u. And this is what we'll be using as the substitution method. So some questions will normally give you a value for u and you'll use that within the question. However, this one does not. So we have to choose our own. I'm going to say let u equal sine 3x. And the reason why I've chosen this one is it is not only the power that is attached to the exponential, it is also under the fraction, and there is also a cos 3x present within the question, and that will be important later on. So step 2 is to find du dx. Now, when we are using the substitution method, we have to change the dx that is in the question into du so that we can actually integrate in terms of du. Otherwise, we wouldn't be able to do it. And this is a really important step that you need to remember. So to do this, we differentiate our u value by dx. So we get, in this situation, 3 cos 3x. And now we need to rearrange this to get du by itself. And that's really simple. You just times by dx. In our equations, we normally think of dx just being as a separate aside, but in this situation, it's very important to remember that dx is acting as a multiplier on the equation itself. So we resultantly get 3 cos 3x dx. So what is our next step? Our next step is to substitute both u and du into the equation that we've got above. U is very easy to sub in. We just replace sine 3x with u as so. But du needs an extra step because we do not have a factor of 3 within our equation. Now this is actually really easy to correct. However, I knew at A level this was something that I always used to forget. Is what we can do is we can add a 3 in front of cos 3x, so making it a factor, but we need to balance it out so that ultimately it ends up just being where it's 1 times. And we can do that by sticking a third, because as you guys will probably be able to tell, 3 times 1/3 is equal to 1, which means that the equation stays the same. However, now we have 3 cos 3x dx within our equation, and that's exactly what we needed to be able to sub in du. Continuing step 3, we can now substitute in du, so we get a third of the integral 1 over e to the power of u du. So what we have to do next in order to make this easier for ourselves is remove the fraction, because it's a bit difficult, and we can put this in terms of power, which is a third of the integral minus u du. However, from what you can remember, it's not really possible for us to integrate e to the power of a minus. So now we've got to do the substitution method again. So we're going to define w, and we're going to define w as minus u. And then step 6, we need to find the differentiation, so dw of du, of what we've chosen w to be, which is minus u. So dw over du of minus u is simply minus 1. And rearranging to find dw so we can sub it back in is minus du. So now we can substitute both w and dw into the equation. W is really easy, we just replace the power, but dw, like we did with du, needs an extra step again. So here what I've done is I've changed our factor of a third to minus a third so that we can change du into a minus du. And the reason why I'm allowed to do that is because a minus times a minus equals a positive. So it's the same equation. We've balanced it out so it doesn't really have any impact on it. And then I can easily switch that out with our dw. So now to finish step 7, I just put in the dw replacing the minus du, but we still have that minus a third in front. Now we get to integrate because this is something that we can do. So we get minus a third e to the w plus c, and always remember the plus c. Even if as soon as you see that it's an integration question, you put a plus c by the side just to remind you when you're going back over, that would be really helpful. The only times when you don't need a plus c is when you have limits, so the range of a graph that you are looking at. And now what we need to do is substitute the values of w and u back in order. So first we'll start with u because that was the most recent one that we did. So you get minus a third e to the power minus u plus c. And then we just need to do the same with u. So doing that and replacing the minus u, we get minus a third e to the minus sin 3x plus c. And that there is our answer. We've done it. Now, the way that I just did it then was actually a longer method than what I'd actually need to for this equation. The reason why I chose to do that was to show you guys that it's okay if you have to end up using 2 substitutions within your equation and it still works out completely fine. But I will show you the quicker method now. So the first thing that I do is rewrite the equation to remove the fraction. And what I mean by this is just getting rid of the fraction line and changing the powers to reflect this. So in this case, you remember from your knowledge of powers that we can rewrite it as cos 3x times by e to the minus sine 3x dx. Now I'm going to define u, and I'm going to let u equal minus sin 3x because that is what is affecting our exponential. And as with before, I've got to find du. So du dx is equal to minus 3 cos 3x when I differentiate minus sin 3x. So finishing off step number 3, we get du equals minus 3 cos 3x dx when I times by dx. And we are going to substitute both our values for u and du into our equation. So first, u is really easy. We just replace the power of e, and then du, which requires another step because of the minus 3. And we're going to do exactly what we did before and add the minus 3 as a multiplier in front of the cos 3x and balance that out by simply putting a minus 1 over 3 because those combined equals a positive 1, and that means our equation is not affected at all. So now what we do is we take the minus 3 cos 3x dx and replace that with du. And finishing off step 4, this is where I replace the minus 3 cos 3x dx with the du. Now we can integrate, so we get minus a third e to the power u plus c, and we substitute back in the value of u, so we get a minus a third e to the power minus sine 3x plus c, which is the exact same answer from our previous method, just a lot quicker. So if you don't see this, this quicker way of doing it, that's completely fine. Just keep with it, and even if you have to do a second substitution, you should arrive at the correct answer. I wish you all the best with your maths and hope that this has helped you with integration by substitution. And that's us done. I do hope that this helps and you feel a bit more confident with substitution by integration. I wish you all the best with your maths.